Well, this video is about the bamboo farms which you see over here. Now, bamboo is relatively easy to farm, but I've taken an approach here to use, again, turtles, computer-craft turtles, to do the farming. On any bamboo farm, you've got to observe at some point when the bamboo has grown, and the traditional method of doing that, of course, is with the observer. So what happens with these is that as the bamboo grows up past the observer, this one uses a relatively simple technique, which I will demonstrate by breaking the link here, which will send a signal down this column, which is made up of 3 wall sections. And so what happens is when the observer fires here, it pushes this normal piston with the wall section in. That changes the shape of the wall, and that's picked up at the bottom by another observer pointing upwards, which again sends a signal, and that signal sends this block of earth up from where it currently is under the surface of the farm. And so once the block is up, the turtle who is sitting here waiting for it can then move off. So you might say, well, why isn't it working now? The bamboo's obviously grown. And the reason for that, if I click it, it says storage at 80%, farm disabled. So what has happened is that we've got so much bamboo in storage that we haven't got enough capacity for it to do another farm. So it's just sitting there. But it does allow me to show you how the observer works. So this time we'll place the wall directly on top. If you watch what happens to the wall below, it changes the shape all the way down, which is what triggers the observer at the bottom. So we'll put that where it came from. It also means you don't need to use sticky pistons. So the little redstone timer here pushes the wall across and keeps it in place for a fraction of a second, and then the other piston pushes it back again, and that's enough of a signal. And that, as you can see, makes the piston at the bottom push the soil up. So that's a more traditional kind of observer mechanism. And then from there, the code allows the turtle to go and create or harvest the farm. Now this side is a purely computer craft one. If I can go up. What we've got here is a turtle without any tools, modems, nothing. It's just a plain turtle. It's not even got any fuel. And every 5 seconds it rotates to the right and the left. So it's constantly detecting whether or not there is a block of bamboo either underneath it, in front of it, or to either side. And it's sending a redstone message via this modem, which is not a wireless modem attached to the turtle. It's a solid state one. And the message will at the moment say waiting. If I click on that, it says message broadcast waiting for bamboo growth. So it's been waiting so far for an hour, which is quite a long time. Not quite sure why it's taken so long, but there you go. And then at the bottom here, we've got another modem at the back of this one, and this one is, say, waiting for bamboo growth. Oh right, yes, so this one's actually only been waiting for 13 minutes, which is more like it. I need to alter the code in there for it to restart the timer once it has sent a complete down. So this one has been waiting for 13 minutes. I'm guessing it'll wait for another 3 or 4. What I might do is to artificially grow the bamboo, just so you can see how it works. So let me just go back down to the ground here. So this one, exactly the same as its partner over there, is just waiting for, in this case, a message from the back to say, okay, off you go. So if we artificially start that by growing the bamboo, and it will on there. on there. So in a second it should, there we are, message broadcast complete. Now what I should have done at this stage is to reset the timer, but I didn't. So that's something I will need to fix. So as you can see, the turtle at the bottom here has received the message. It's now going, and what it's doing is it's staying one block above the ground and breaking the bamboo. Let's get out of the way here. Then it's coming back on itself, so it's doing like a very small circular motion. So it started here, goes across that row, back this way, back along here, then it goes to the next row along, which is the one it's currently doing now. When it gets to the back there, it'll come back and come back on itself on this row, and so on. So you've got this circular motion, and the reason for that is that as it goes through breaking the bamboo, it uses the turtle.suck method to suck up any broken pieces here, but it's not very efficient and pieces are still falling long after it's passed. So as you can see, there's quite a lot of loose bamboo here, but by coming back on itself and then redoing the same row, you'll see it picks up 90% of the bamboo that has been previously loosened. So it actually is a very efficient way of doing it, so that it doesn't use too much fuel by going over the area too many times, but it does capture most of the bamboo. The great thing about it is once it's gone through, it leaves the bamboo that it's already cut continues to grow almost immediately, so that by the time it's done the whole area, this half is already halfway grown. The design of the farm as a whole is more decorative than necessary. All that's required for this is that you have a solid wall, that you have a grassy patch that does not have any bamboo, with at least 2 blocks border between the outer wall and the bamboo farm, and that seems to allow for the capture of all the bamboo. I thought at first that if the bamboo is very, very tall, that it might fall a long way out of here, but it doesn't. It seems to fall within 2 blocks of the plant itself. So that's how this one works. Now what it does every so often is it checks to see how much bamboo it has captured so far, and then converts it into blocks of bamboo by crafting it. The reason for that is that obviously the stacks here would very, very soon fill up on a large farm, and it would run out of capacity before it had a chance. But by converting it to blocks of bamboo, which obviously reduces its or increases the capacity by 9, because it takes 9 bamboo to make 1 block. So that's a very efficient way of sort of crafting on the go. Now the reason it's got, if I can click on it here, you've got this built-in barrel or chest, is it uses that as part of the crafting process, which is what it did when we caught it a moment ago. So that as it comes to an end where its capacity has got to the point where it needs to, yes, then I think the next time round there'll be enough bamboo in there that it requires crafting. So let's go back to this side. Can't remember what I set the limit to now, whether it was 2 stacks. Actually, it might have been 4 stacks. Yeah, thinking about it, I think it was 4 stacks. So let's wait here. What we'll do is I've picked up some accidentally by getting too close to the turtle, so I'll just pop that. If I can cut hold of it, I'll just pop that inside the turtle. That's it. So it should hopefully start to craft it again soon. If not, if it hasn't got enough to craft by the time it reaches home, then it'll do it then. Oh, there you go. So it pops the chest on top, empties everything into the chest, then pulls back a maximum of 32 bamboo per slot, crafts it into bamboo blocks, and then returns everything from the barrel and then breaks the barrel and carries it with it. So it's quite an efficient way of crafting. So it's only got another 2 or 3 runs to do. So it comes back up here, goes round and so on. So let's see. And then once it's finished gathering all of the supplies, it will then return back to the start. I have a feeling, because of the way this farm has been designed, it goes back this way, so I'll just wait for. So it's realised it's reached the edge. Reach the edge there. As soon as it reaches the chest, turns round, and again it crafts any bamboo into bamboo blocks. And the next thing it does is to take blocks of bamboo individually, craft it into bamboo planks, which doubles the number, and then drops the bamboo into the storage below. So that's now waiting for the next growth cycle to occur. So that's how this one works. This one is exactly the same, except it's using a more traditional observer mechanism to discover when it needs to run, but otherwise they work the same. It's the same piece of code in both turtles. They adapt for the type of observer that's used. So we'll have a look at the code now. Right, so this is the the bamboo farm. I'll close off the kelp farm so that it doesn't confuse us. So it's the bamboo farm code. So similar to the kelp one, except that this one uses a config file. So it first of all checks whether the config.lua file exists, and if it does, then it requires it and uses it. Otherwise, it takes you to a part where you can create the config file by entering the width, length, size of the border, whether it's a right to left or left to right layout, and whether the detector is a piston or network method. So this is an example of a completed config file. Okay, so this is the config file for this particular farm. So the detector is of type N, which is network. The layout of the farm is to the left. What that means is, if I drop back and show the farm, that given if we're standing at the front of it here, storage is on the left hand side, whereas over here storage is on the right hand side. So this one has a different config. So this one is on the left hand side. Let's just put the code back again, which means that if the layout's on the left, then I've put this one called turn, which the config editor doesn't specifically ask you for. It's always the opposite. So if the layout's on the left, then the turn's to the right, and vice versa. So if the layout was to the right, the turn will be left. That's used internally to move the turtle to the right direction. This one, the length of the farm is 9 and the width is 9. So that's the kind of the growing area. That's the length and width of actual bamboo. And the border is 2. So it uses these details inside the code here. So it looks for the config file and loads it in if it's required. The next thing that's important is it's got to find a chest inside the turtle. Otherwise it won't run, because it can't craft without that internal chest. So if somebody's taken it out, or you've broken the turtle and moved it or whatever and forgot to put a chest in, this will do that for you. So it just looks for a chest or a barrel within the turtle, and if it succeeds, it assigns the type of storage to this local variable up here, storage, which is of course, given that this is Lua, although it says local storage, this means it is local to the whole of this script, including inside all of the functions, which is completely the opposite to what Python is if you're a Python programmer. So that means that we can use it anywhere in this script. So the storage is then given a value, which is whether it's a chest or a barrel. So we've got the checking for the chest is okay. If there isn't one, it says unable to find a non-ball chest or barrel, add to the inventory and reboot, and then it returns, it stops working. Then it goes straight then to craft bamboo. That's so that if it's been sitting somewhere while the chunk was unloaded and there was bamboo in there, it would just craft it for the first time anyway, just to make sure that it clears the inventory. Then we've got this ability to check whether we are at home, and if we're not at home, it then finds home. Then it orientates itself so that it's pointing in the right direction. If we check that, so it's checking what's in front of it, whether it's dirt or grass. Finds the modem behind it, then it knows that it's in the right place, and then it just has to turn back 180 degrees and it's ready to go. Same if it finds a wall behind it, then it's also ready to go. So that's what controls that. So that gets the orientation right. Then the while loop here just runs continuously, so that it will again check if the size of the storage is at greater than 80%. I'll just show you how it does that. Check storage level. This is what that does is it uses the peripheral and inventory APIs to determine storage contents. So we've got this local variable chest, which is peripheral wrap bottom. So that's where the storage chest is. It's at the bottom of the turtle. So if you wrap that chest, you can then use the inventory API, which is chest.list, to find out what's in there, and then you count how many you've got, and then it will return the total count of how many items you've got in there, and the chest size, which is the number of slots that the chest has. So a double chest will obviously have double, I believe it's 58, 59, something like that, slots, whereas a single chest is 27, I believe. It doesn't really matter. And then you can calculate from there whether or not the chest is too full, and if it's too full, then you stop. So this is what checks for the whether or not to carry on. So assuming that we're not stopping and waiting, then we are waiting for the turtle to begin. So the wait one is slightly different depending whether it's using the network or whether it's using the standard wall. So if we're config.detector is a piston, then we're just simply waiting to see whether we detect something in front of us. That means we're waiting for the dirt block to pop up via the piston, and as soon as the block has appeared, the pistons push it up, off we go. Whereas if we're waiting for the network, we're using this RedNet receive API, and then if the message that we receive says complete, then off we go, and then the farming process starts. So it was easy to adapt the code to work with both types of detecting mechanism. Next thing we've got is, after the wait, is to go to the farm. So that makes that short journey between the chest and the farm itself. So in order to do that, I use turtle.tig and turtle.forward anyway, because even if we're on the network version where there is no block to dig, these commands have no effect, so it really doesn't matter. And if there is no dirt to place down, then it won't place it down, so we can leave that exactly as it is. And then we're going up one, forward, and then we're using the config border width and the config turn and config border to produce this code, like up one, forward two, left one, back two. And that uses the go mechanism up here, which follows a path based on this command list that's sent to it. So you can look through that and see how that works. It's just kind of a quick way of combining a series of commands into up, down, back, forward, left, right, and the number, so that it follows them. It will even include excavate, which is dig, in that command list. So that's how that one works. Then once we've got to the farm, we actually do the farm, which is the one that runs backwards and forwards as I showed you. Again, that's got some sub-libraries inside it. So based on the width and the border, it calculates how many steps it should go. So it'll craft bamboo at every time it changes direction, and the craft bamboo checks to see how many bamboo there are. If there's enough, it will craft it. If there's not, it ignores it. So it's kind of put in every time. The reposition one here controls whether the turtle, once it's turned, moves once or twice or 3 times before dropping back down and doing the next column. So that's what controls that circular motion of the turtle going backwards and forwards. Most of the code is fairly self-explanatory, so I didn't want to spend too much time on it, because I know that's probably not the interest of most of you watching this video, but it's there if you need it, and you can always ask questions if you need to in the comments. So I think that pretty much covers everything. So again, the collection of this bamboo, in this particular one, I think it stops at this chest. I don't think it goes any further. But this one on this side, because it's been running a lot longer, goes into a hopper, which goes into another chest, which is completely full. That one goes into yet another chest, which is also completely full, and that one is picked up by the modem here. Oops, I just turned it off. I'll turn it back on again. I hope that gives you an idea of how you can use Computercraft to make a bamboo farm which will work in conjunction with the kelp farm over here to provide enough power for all the smelters and burners and whatever we've got over here. So we'll go through the storage system at a later stage. This one is horrendously complicated. So if we were smelting items, we can then choose what we want to smelt, and as I say, I'll go through this on another video, but now we know that we can use either bamboo for small quantities, put them into the correct places, or if there's a large quantity, we can use the dried kelp blocks, and those can be transported via the network cable, which seems a bit odd, but there you go, that's how the Minecraft network cables work. So we'll look into that on future videos.